So this lesson is about collision theory, which is a very important concept that we have to understand in order to understand why rate of reaction is affected by factors, for example, like temperature or surface area and things like that, which we're gonna learn about more later. But the main thing to understand is that if two particles collide, you're not going to end up with getting products. So just because two particles collide, there's not going to be any products. So the first thing we have to understand is the first factor that actually we need in order for products to be formed is that molecules need to have sufficient kinetic energy. So factor number one is molecules need to have sufficient kinetic energy. And what does that mean? So think about it this way. These are my reactants, and they have to make me products, but not every reactant can go to products. The thing is, we talked about another factor, which was activation energy, which was the distance between the potential energy of reactants and activated complex. This was called activation energy. So as you remember, we defined it as the minimum amount of energy required for the reaction to take place. So basically, looking at these two reactants, they have to minimum have some kinetic energy equal to or greater than activation energy in order to make the activated complex first, so that once activated complex is formed, then we can make the product. So there's no way the reactions can jump to products without having that sufficient energy. So the first factor says molecules need to have sufficient kinetic energy, which is the kinetic energy greater than or equal to activation energy. Second factor says molecules need to have correct geometry. So what does that mean? So the only way I can explain this is just by looking at an example of the molecules AA and then again BB. So this is AA, I'll write BB this way. So let's say if they want to end up making AB for me, so A attached to a B and A attached to a B, the only way this can happen is that the bonds between A has to break, and then the bonds between B and B has to break. So maybe I should show a bond over here. BB has to break, and then new bonds have to form between them. So this is, for example, an example of a collision with the correct geometry. But imagine if A and A come this way, but then B and B approaches it this way. Is this going to give me the correct geometry? Is this a correct geometry to make the activated complex? No, because there's no way from this thing I can actually make this. So the best case scenario over here is the bonds between A and A can break, and then the B and B can break, but you never can make this product. So that's why this reaction cannot happen. So this was the second factor that it's required for the reaction to happen. So once again, factor number one, molecules need to have sufficient kinetic energy, which is the kinetic energy greater than or equal to activation energy. Factor number two is molecules need to have correct alignment or geometry. And this is just a concept. So again, we never see how they look when they're colliding, but it's just a concept that you have to understand that, again, just because two collisions and a collision occur, it doesn't mean that you're going to form a product. So, but once you have factors number 1 and 2, then we're going to have successful collision. And then when we have successful collision, that means now the products can form.